So let's see the multinomial theorem. So we will understand this theorem with a question. So read the questions that in how many ways three persons A, B and C having 6, 7 and 8 1 rupee coins respectively can donate 10 rupees. So here if you try to write the equation, then you will see that here three persons are there, x, A, B and C. So suppose A gives x1, B gives x2 coins and C gives x3 coin, and total how much rupees should be become 10 rupees. So it will become 10. And what is the condition? That A, that is x1, is A is having 6 coins, so he can either give either he can give 0 or 1, 2, 3, at max 6 coins. Similarly B can be give, x2 can be from 0 to, he can give total 7 coins, so 7. So similarly the third person can give 8 coins. So you can understand this is the like equation which you will get. This is the condition and this is the equation. So if you solve this equation, so you will get out the number, like total number of ways this is possible. So that is what we are like seeing from the multinomial theorem. So this is the multinomial theorem. So in multinomial theorem, that these types of like equations you have to solve. So if you try to solve this, so how you will solve it? So let's see. So here the number of ways to having such solutions is coefficient of x के power 10 in 1 x squared so on till x के power 6 into 1 x squared to x7 into 1 x squared till x8. So if you somehow like find the coefficient of x to the power 10 in this product, so you will get your desired answer. So now our challenge is to find x to the power 10. So the first thing is this is a GP series, this is a GP, this is a GP and this is a GP. So let's like solve it. So coefficient of x power 10 in, so if you try to write the this GP, it will be 7 minus 1 minus x, because we know that if GP we get the sum of the GP is 1 minus r, which is where a is the first term and r is the common ratio and n is the number of terms. So like let's like it is this thing. So if you like write the sum of this GP series, you will get 1 x to the power of 8 1 minus x. Similarly if you write for the next one, this GP series, you will get 1 into x to the power of 9 by 1 minus x. So now you have to find the coefficient in this. So let's write. So coefficient of x to the power 10 in, so let's x to the power 10, take the denominator in the numerator, 1x9 into 1 minus x to the power of minus 3. So now here you have to understand one concept, because like if you don't understand this concept, you will face difficulty. So you have to learn one thing here, that coefficient of x to the power of n in 1 minus x to the power of minus r is n plus r minus 1 c r minus 1. So you have to learn this. If you learn this, so like you can understand the entire upcoming So what we will do is that we will first multiply this 3. So if we multiply 1 minus x to the power 7 into 1 minus x to the power of 8, 1 minus x to the power of 9. So first multiply these two. So we will get 1 minus x to the power 7, and then when we multiply x to the power of 8 to 8, so 1 minus x to the power 8, and we will ignore the higher terms more than like x to the power 10. So if you multiply x to the power 8 with x to the power 7, you will get x to the power 17, like x to the power 15. We will ignore that. So now let's multiply these two. So when you multiply it with this, so here again you get 1 x to the power 7 minus x to the power 8, and like when you multiply this x to the power 9, and when you multiply further terms, so all the terms will be more than like higher than x to the power 10. So this, so we will consider only till here. So because we want the coefficient less than x to the power 10. So we have 1 minus x to the power 7, 1 minus x to the power 8, 1 minus x to the power of 9 plus dot dot 1 minus x to the power of minus 3, and you have to find the coefficient of x10. So like we will multiply it from inside, so it will give us 1 to the power of minus 3 minus x to the power 7, 1 minus x to the power of minus 3, then minus x to the power of 8, 1 minus x to the power of minus 3, and then for x to the power 9, 1 minus x to the power of minus 3. So now, and here you have to find the coefficient of x to the power of 10. So if you, for this, if you use this formula which I was talking about this one, so n plus r minus 1 by c r minus 1. So now like when if you try to find the power of x to the power 10 in this, you will have n plus r minus 1 c r minus 1, the formula which I was talking about earlier. So here n is 10 and r is 3. So like doing this for others also, like writing it fresh, 10 plus 3 minus 1 c 3 minus 1. So in the second one, this in the second term, this term, you already have x to the power 7 over here, so you only need x to the power 3 from this expression. So our n value will be 3. So here 3 plus 3 minus 1 c 3 minus 1. Similarly for here, you have already taken out x to the power 8, so you only want x squared coefficient from this term. So here it will give us n is 2 plus 3 minus 1 c 3 minus 1. Then the final term, already you got x to the power 9, so you just want x to the power 1 from this term, then it will become your x to the power 10 coefficient. So here your n value will be 1 plus 3 minus 1 c 3 minus 1. So our r value is same for all the all the 4 terms. What we will get here, 10 plus 2 12 c2 minus, here you will get 3 5 c2, then here you will get 2 4 c2, then finally you will get 1 3 c2. So like you have to solve this. So this is the final number of ways that you can distribute like 1 rupee coin, like total number of ways in which the 3 persons A, B and C can distribute their 1 rupee coin so that they collectively donate 10 rupees. So like I hope that I was able to explain the concept really well to you. Thank you.